Good afternoon. We're going to get started with our webinar in just a few moments. Okay, it's 2 o'clock, so I am going to get started with our webinar. Good afternoon, everyone, and thank you for joining us on our call today. My name is Nicole Van Wert-Quincy from Transcat, and I will be your moderator this afternoon. Our webinar topic is streamlining instrument calibration with calibration management software and documenting field calibrators. It's being presented by both Jim Shields and Bob Krebs from Fluke. Jim is the product manager for the process calibration group for the Fluke Corporation. He's been active in the ISA and has actively supported and developed instrumentation curriculum throughout his career. He has worked in the field of calibration and metrology, field and bench for over 40 years. Bob Krebs is the Fluke Process Tools product specialist, providing engineering level support and technical product training worldwide. He has over 30 years experience providing technical support and training for various industries. He did computer printers, fiber channel switches, and for the last 6 years with Fluke and the Process Calibration Tools Group. We expect the presentation today to last roughly 30 minutes, and then we will answer any questions that have been submitted. During any time of the presentation, you can send questions through the question box to the right in your webinar controls. I also wanted to mention that the webinar is being recorded. You will each receive a follow-up email with a link to the recorded webinar and the slides of today's presentation. At this time, I'm going to turn the presentation over to Jim and Bob.
Thank you, Nicole. Welcome, everybody. For our topic, we have an agenda that I would like to share with you. To begin with, we're going to talk a little bit about instrument calibration, the challenges, elements of calibration, and of course, reasons to calibrate. And then we'll get into the meat of the topic, establishing a calibration maintenance management program, using calibration management software. CMS is the abbreviation we'll be using for that from time to time. And it will show how you could use the software to manage instruments and their records, interface with field documenting calibrators, and predict instrument performance and minimize maintenance costs. In addition to the software, the other critical element to the process is the documenting process calibrator, which can be used to manage procedures or tasks downloaded from the calibration management software, perform field calibrations and adjustments, record and document field calibration results, and then upload field calibration results to calibration management software. And then we'll talk a little bit about the benefits of a paperless calibration management program. And besides the content in the PowerPoint slides, Bob Krebs, the technical product specialist for our group, will also be giving us a live demonstration of the calibration management software and the work stream for documenting field calibrations, reviewing the data, and looking at the reports. So that's kind of the agenda for today. So to begin with, let's discuss why calibrate. Well, there's a variety of reasons to calibrate. One reason being because you are regulated or have oversight by regulatory authorities that say you shall calibrate particular critical instruments. Examples, of course, regulations, standards, and trades. One example is custody transfer, the transfer of materials from one owner to another, common in gas pipelines and oil pipelines, the transfer of product from one owner to another. Internal and external quality programs like ISO 9000 that help define and maintain product quality within a facility. And then, of course, to maintain plant safety and uptime, and then to meet regulations like the EPA, the FDA, the NRC, and OSHA, and other mandated regulations. The critical control devices in the plants, it's not an option to calibrate those devices. They need to be routinely maintained. Next. So Another element of calibration and the requirement is that all process instruments change. They're in a harsh environment. The time and stability, the temperature changes, humidity, environmental exposure, vibration, and wear and tear cause these instruments to change over time. And because of the uniqueness of the applications, no two instruments are going to change exactly the same. So since those changes cannot be predicted, calibration is required to ensure the devices are performing as expected to properly control and regulate critical processes. Also, scheduled calibrations help reduce process downtime risk. By knowing the devices are performing as expected, it helps improve the performance and reliability of critical assets in the plants. And then product quality and yield is critical. Calibration helps processes stay comparable to traceable calibration standards. That helps the devices perform consistently. It helps minimize process deviations and improves product quality when these critical devices are reporting their measurements accurately back to the control system. And it helps drive process optimization and cost savings. Next. And then, of course, industry changes. Regulatory forces are not decreasing, but rather increasing. And the plants aren't getting any smaller, but shrinking maintenance budgets are reducing maintenance staff. This is causing the need to drive efficiencies and the need to do more with less with your maintenance budget and with your skilled maintenance personnel. And experienced instrumentation professionals are retiring. The term I've heard used is the brain drain. The experienced folks with the tribal knowledge in the plants are retiring, and more the technical and vocation schools are being asked to fill the needs to provide skilled people into the facilities, but they don't have the background and knowledge of the folks that they're retiring, so there's a little bit of a uptime to bring those folks on board. And plant modernizations lead to control system changes. And anytime there's change, there's a learning curve on how to maintain and keep the processes working within limits. And then there's competitive pressures offshore. The need for the plant to be optimized, streamlined, and have maintenance practices that reduce the costs to keep the company competitive, both from the quality perspective as well as from the cost perspective. Next. So a couple key elements for process calibration: the equipment, the procedures, the instrument documentation, in this instance, the calibration management software, and trained personnel, people trained to understand and know how to use these tools and familiar with this process. The benefit is consistent process and performance, efficiency, improved product quality, reductions in downtime, improved safety, regulatory compliance, and maximize the use of skilled maintenance personnel. Next. So some definitions on calibration. Calibration is, by definition, the comparison of a measured value to a traceable measurement standard. Notice the definition of calibration does not have the word adjustment in it. Adjustment to agree with the standard is required if the comparison shows that the actual value is unsatisfactory. So adjusting to agree can be part of the calibration process, but is not defined as calibration. Calibration is simply the comparison. Accuracy is the closeness of agreement between an observed value and that of the traceable measurement standard. Adjustment, of course, manual or digital compensation of the output signal of a device with a known input signal applied. Necessary if a device is not performing as required. Not necessary if the device is performing within its expected tolerance. We need to understand the adjustment tolerance, which sometimes is different than the pass-fail tolerance. And if you're working with smart devices, a digital communication tool is required for doing the digital adjustment. Remember, adjustment is part of the calibration process. It is not calibration by itself. Next. So this term traceability that I used, a traceable calibration standard. Traceability, by definition, is the paper trail that goes from the device that's being tested out in the field to the calibrator to the national standards or the bench calibration tool. So there's an unbroken paper trail of the device that's being calibrated in the field, the paper trail of the calibrator that calibrated the device when it was calibrated, and then indeed even the calibrator that calibrates the calibrator, there's traceability on its calibration and its traceability. So there's an unbroken chain of documentation and paperwork from the device that's being calibrated in the field all the way up to the national standards. And documented proof is required in many instances when in the event that an audit is being performed. So from the instrument test equipment side, we need traceable calibration tools. So from the traceable tool perspective, the source function, we need to be able to source temperature. Okay, the most common method being the electronic simulation of thermocouples and RTDs, but this does not test the sensor that's installed in the process. Alternate method for sourcing temperature is the use of a dry block or a temperature calibration bath. This tests the temperature sensor and the transmitted electronics and provides a more complete calibration of a particular process. However, it does require another piece of equipment to be carried out into the process to perform this calibration. For pressure, you need a hand pump or some other means to apply pressure to the unit under test. And to know what that pressure is, you have to have some form of a pressure measurement reference to measure the pressure generated by the pump, typically a gauge, a pressure module, or a pressure calibrator. And since the pump is external, and this is referred to as a transfer standard method where the pressure is being generated by the pump and then the actual pressure that's being applied to the UUT is being verified by the pressure standard that's making the measurement. Other electronic signals, if we're doing flow or speed and rotation, being able to source frequency, sourcing current for testing I to Ps, and the inputs and outputs of control systems, and of course voltage for signal conditioners and analog I/O that have 1 to 5 or 0 to 10 volts inputs. Okay. So for measurement, beyond the need to source the parameters, you also need to be able to measure the output of a critical device. You need to be able to measure temperature from a thermocouple or an RTD in the form of a thermometer. This allows you to measure the process temperature with the reference probe and directly compare with the indication on the control system display. So that's a one-point comparison. Disadvantage of that method, of course, is that you can only test the 1 point. You can't do a multiple point test, but for a check standard or in between routine maintenance, it's a good way to confirm and have confidence that the actual values that are being reported to the control system at the control point are accurate. Being able to measure pressure, measure the pressure output, for example, from an I to P, or measuring other pneumatic control signals, 3 to 15 psi, etc. And measuring the other electronic signals, of course, measuring frequency for flow, speed, and rotation, measuring current for the output of all transmitter milliamp loop signals, and measuring voltage for signal conditioners and other devices that have voltage outputs instead of milliamps. Next. So why document calibration and how? Calibration records may be required for regulatory oversight. They may be required for quality standards. They may be required by the customers of your products that you manufacture. These records can assist in the understanding the performance of a process. They can be used to determine a device's suitability for a process. It helps assess if a device is in need of repair. For example, if it's repeatedly out of tolerance when it's tested, may indicate that it either needs repair or replacement. Or in the event that the device is nominally out of tolerance, the calibration records can prompt the user to determine if perhaps the maintenance intervals need to be tightened, and the device maybe needs to go from a 1 year interval to a 6 month interval, for example. Conversely, If the device is never out of tolerance, the maintenance intervals and the documented records can be used to determine if the maintenance interval can be extended and reduce the maintenance costs of that particular asset. Calibration records can be recorded in a variety of ways, the most common being manually recorded on a paper form. They can also be recorded on a palm device or typed directly into a portable computer. More often than not, though, when they're being typed into a portable computer, they're being done with the information from the paper form being typed in, so there's some opportunities for transcription errors as well as interpretation errors. But calibration management software plus documenting calibrators enables easy documenting and analysis of field calibrations. Next. So, thinking about how do we get started? How do you get this set up? To begin with, you need to define the test equipment that you're going to be using in the calibration management software. We're going to show the Fluke examples that are in this domain, but Fluke is not the exclusive manufacturer of devices and software of this type, but we will use the Fluke products as examples. To begin the setup, you first need to identify the critical instruments. Don't try to boil the ocean. Identify the devices in safety instrumented systems, things that are environmentally critical and may have oversight, quality critical, and revenue critical. So once the critical devices have been identified, that's the place to start. Okay, there's other tertiary devices in the plant that, in some of the plants, they run them to fail. It may not be the best mode to operate in. It could be that they need to be added to the system, but we ought to begin with the critical devices. So once you've identified the devices, then define the interval to maintain the desired accuracy and allowable deviation of that device in the measurements that it's reporting back to the control system. At the end of its calibration interval, the instrument should be in tolerance when tested. If the device is out of tolerance, either the device is not accurate enough for the process that it's testing, or it needs to be tested on a more frequent interval to ensure that it's within the desired accuracy to keep the process measurement under control and within limits. Specifications and test tolerance need careful consideration. Now, many manufacturers will post an advertised value of their accuracy, and this can be misleading. It's important to dig into the data sheet and make sure that you're looking at the total performance of the device, not just the 24-hour specification with a temperature specification of 23 plus or minus 1 degree. I don't know of many of any process plants in the United States or Canada, for that matter, that have accuracies and conditions that would allow those reference uncertainty specifications to be claimed from the process devices. So it's important to understand the total spec. The test tolerances of the devices should be specified by the process engineer that is aware of the process and knows what the allowable deviations are. And when you're doing a calibration, the accuracy of both the instrument being tested and the calibrator that's being used need to be considered. So once this is process is set up, the procedures need to then be defined for the identified critical tags. Next. So once the process is set, then the execution. Identify the tags that need calibration. Organize the work into logical work routes. For example, identify the tags that are due for calibration in the next 30 days in a particular process unit to make the route for the technician effective and make the technician effective in his route so he's being able to be more efficient. Collect the necessary procedures, documentation, and tools. Then, once at the device to test, isolate the device from the process, lock out, tag out if warranted for a particular device for safety or for process safety. Then, once the device is isolated, perhaps if it's a pressure device, the reservoir needs to be drained and fluids removed. Connect the calibrator, perform the as-found test, and document the results. Once the results are documented, adjust the transmitter. If the measured errors are greater than the adjustment threshold as defined by the procedure. When I say adjustment threshold, the adjustment threshold might be 50% of the pass-fail. You might pass the as-found test, but adjustment still might be required if the errors are outside of the adjustment threshold. Once the adjustment is performed, then confirm that the device is within tolerance by performing the as-left test and document the results. Complete the documented record with the tag ID number, time, date, serial number of the tag, the test equipment used, its calibration data, and of course, the person performing the work. Next. So documented calibration requires as-found data. Next. Testing an instrument to determine the as-found performance. As you can see in the result, we have a calibration result. An accurate knowledge of the source value is required. The source value and measured values need to be traceable. The total uncertainty of the source should be 3 to 4 times better than the device under test. Next. So here's an assessment of pass-fail for the as-found. Note the failed specification. The specification of 1% in this particular instance was exceeded in the final test of this as-found test. So the milliamp signal was out of tolerance. So adjustment is required. Next. Here you can see the graph of the as-found values versus the tolerance line. Notice that the found errors exceed the allowable milliamp deviation. So again, adjustments required for this particular tag. So we need to, once the adjustment is performed, the test needs to be rerun to verify the adjustments and confirm that they put the device in tolerance. This as-left test documents the condition of the transmitter after the adjustment was performed. The time and the date need to be documented, as shown in the upper left-hand corner of that screen, and the instrument tag, serial number, and technician data are documented and recorded as well. The result, all of the found deviations of the milliamp signal are within the test tolerance, so this shows a passing test. So you've documented the as-found, performed the adjustment, and documented and recorded the as-left. So now we've kind of talked about the process and setting up the process, we're going to walk through an actual example of what it looks like to do this calibration. Next. So why use a documenting calibrator? They do have the capability to source and measure and have traceability. They automatically capture results, date, time, user, and tag information. They eliminate manual transcription and legibility errors, and they eliminate what we refer to as pencil-whipped results. Next. Now that's not a term that I made up. Pencil-whipped is actually a common term that I've come across in many of the folks in the plant, where someone is paper documenting a result and will actually write down the passing information rather than what's actually being measured to avoid the difficulty of having a failure in the field. So it's not a slang that Fluke developed. It's one that I indeed heard from the process guys in the plant that are doing documented calibrations. The documented calibrator ensures the calibrations are performed for the procedures, and when coupled with calibration management software, you have a paperless system. It assists in complying with regulations and audits, and many of the documenting calibrators have hard communication built in. Next. So the calibration management software manages calibration records for field process instrumentation, helps print reports, run queries for instruments due for calibration, help assess, schedule, and manage the workload. They do allow connection to documenting process calibrators. They can load tasks into the calibrators as well as upload the results. Documented results enable analysis for drift, reliability, and maintenance costs. And many of the calibration management packages have the ability to communicate to CMMS, calibration maintenance or computerized maintenance management systems like SAP, Oracle, and Maximo, so they can essentially update the maintenance flag and document the cost for calibrations for accounting purposes. Next. So why use calibration management software? Calibration management software completes the documenting solution when coupled with a documenting calibrator. There are many different solutions, from fully integrated computerized maintenance management systems to standalone calibration management systems. They vary in complexity and price from under $4,000 up to $100,000. And here's some examples. The example we're going to talk about today is Fluke's DPC Track 2. There are more enterprise centric solutions such as Prime Technologies ProCal, Emerson's AMS, and Yokogawa's PRM. Meridium and Intergraph Smart Plan are the examples that come to mind as far as supporting the documenting calibrators. Our example, DPC Track 2, is an entry-level single-user calibration management software application. It is upgradable to ProCal V5 Enterprise in the event that multi-user access is required or connectivity to SAP or some other back office system is required. But the modern calibration management software packages are easy to use and deliver good reasons for adoption. Next. So what should a calibration management software package do? We should manage and document the process instrumentation's performance, be able to create procedures for download to documenting process calibrators, or if not working with a documenting process calibrator, print a method sheet for manual documentation, upload results from documenting process calibrators in store for later retrieval or analysis, print reports to support ISO 9000 or other documentation needs. They should be able to search particular tags and report their history, search for tags due for calibration in the past or future, and keep track of all tags touched by a particular piece of test equipment. That's particularly useful if the calibrator is returned for recertification and you find out that the calibrator that you've been relying on has fallen out of tolerance. You can run a reverse traceability report and find the devices that have been touched. The instrument search query allows you to find tags that are due on a particular cal date, or search by tag ID or serial number, or you can do nested searches, calibration due date within 30 days, for example, in tank farm 3 that are all pressure. And Bob, when he gets into the search, will give us a quick show on what the search criteria can look like. Next. 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 So this is the data entry screen. So when a tag is initialized, the manufacturer is input, and then we describe the data for the transmitter, the inputs, its outputs, and its expected tolerances. Next. And then once the tags are all loaded into the database, they can be searched, for example, by due date, and selected for loading into a calibrator. So in this instance, we've got tags in the load list off to the right, and they're going to be loaded into the documenting process calibrator. Now note that the warning results of the calibrator will be cleared before the tasks are loaded. That's a common mode to keep the data in the calibrator fresh, and it is suggested that the data in the calibrators be unloaded before fresh tasks be loaded into the calibrator for performing the work. Next. So now Bob's going to convert over to a live demo. He's going to create tags. He's going to show the error percent template, sort and find devices in the database, and load tags for a calibration route into the Fluke 729 pressure calibrator. Go ahead, Bob.
Okay, let me drop this down, and hopefully everybody can see the software up on the screen now. So I've got our software package DPC Track 2 running. Of course, one of the main things you want to do is to be able to load your database with the instruments that you have. And if you notice up here is the instrument tab or button. And when you click on that, it will bring up the instrument screen. The one I have shown here is a pressure transmitter. Tag ID is up in the corner called PT100 here. But when you create a new device, you need to put in the information about that instrument as well as tell the document and calibrator how it's going to do the calibration. So if I click on calibration points, you'll see here all the information about that device. So you'll notice the input type in this case is pressure. Depending on what type of transmitter that you're calibrating, whether it's temperature, pressure, whatever, this is where you'll put the input type. In this case, we have it set for a range of 0 to 100 PSI. Then on the output side, you want to fill in what the output is of this device, which in this case is, it's a 4020 output milliamp transmitter. Also, down below, you'll see the accuracy. So this is where your company determines what the accuracy is of that device. In this case, we have it set for percent of range, could be set for percent of reading, and then you also have the actual value. In this case, we have it set for 0.5% accuracy. Up on top, up here is the number of calibration points, and this is your test strategy. How many test points you're going to go out and calibrate on that device. So this one we've got set for 5, and you'll notice down below, here's our 5 set points from 0 to 100 PSI. And notice when it's calculated in, it also gives you what the accuracy range, in this case, like for 4 milliamp output, it's going to go from 3.92 up to 4.08 is acceptable. So once you have one of these created, you've got to, of course, create that calibration information for every device you've got. And you could have hundreds of these things. There's a couple shortcuts to make it easier. If you were to normally just create a new device, you'd have to fill all this stuff out, which is not any fun. So we've got, there is an example here where you can copy current record. If I click on copy current record, notice it'll bring up the information about that device, but a lot of stuff is filled in for you already. You just have to put in the serial number, the tag ID, but if you click on calibration points, everything's copied over. So it makes creating new devices a lot easier, especially if you have, like 20 or 30 instruments that are the same, as far as, pressure, input, milliamp output, and the type. So that's what makes it really easy to use. So that's basically, what you do when you're creating a device. Once you've created those things, now you're going to want to connect up to your calibrator. So if we go to the upload download screen, and if you go ahead and do a search, you go down here and refresh. And once you have your calibrator connected up to your PC, when you do the refresh, it's actually going to go out and search for, whatever calibrators are connected to the USB ports, and there can be, up to 250 USB ports. So that's going to go out and search for those. And while we're doing that, if you notice on the left, this is where all your devices are that you could send down as a task. Now, normally, you're only going to want to download, whatever the tasks are you want that technician to do for a shift, which is probably 5 or 6 for a day or whatever. But you can do pretty much 50 or more if you really wanted to. As you see over here now, you'll notice that my 729 is connected up to COM11. So we're going to click on that, and then if we scroll down, we're going to look for that PT100. Well, it's not in here because it's not actually due for calibration. So we could either clear out the date and refresh, and that would bring everything up that's on the screen, and there's that PT100. Or you can do queries such as searching for locations, identifying, and there's an easy one by configuration. If I've got things grouped together, let's say I've got something called a furnace or a boiler they're connected to, or a loop or a location, you'll see here's all these devices. I could click on all 3 of these and download it. In this case, I'm just going to click on that PT100, and when I click on it, notice it comes up on the screen. When I'm ready to download, I just click the initiate download button, and you'll get that screenshot that says, okay, all my existing procedures will be cleared. And that's pretty much how that works. I'm not going to download because I've already got some stuff in my calibrator I don't want to mess up. So I'm just going to stop that there. Let's go ahead and bring up the PowerPoint again. And let's see if I can do this quick enough to get Jim back on the horn. There you go, Jim.
Thank you, Bob. Next, please. Okay, so once the calibrations have been loaded from the software into the documenting process calibrator, there is a task list of tags that are into the calibrator itself. They're listed by tag number. And notice not only is the tag number shown, but also the usage count. So as the calibration is performed and completed, the usage count will increment from 0 to 1. The technician can use this as a punch list, essentially. This is the technician's route to go out and perform. It can be either self-loaded for the technician, or a supervisor can assign the route to the technician to perform for the day. The usage count indicates whether or not the task has been completed using the downloaded task. So the supervisor, on completion of the route, can look and see that the procedures that he downloaded to the calibrator were performed. And the tasks must be performed for the usage count to increment. Next. So once the task is selected in the calibrator, you can see the predefined procedures automatically filled in with the test parameters. In this instance, you've got a 0 to 100 psi pressure transmitter, output 4 to 20, the test tolerance of allowable deviation of 0.2%, a 3-point up-down test, a settling time of 5 seconds after stable, and the transfer function is linear. So this is the basic configuration that was downloaded from the software that Bob just showed you. There's also a leak test in the event that you wanted to verify that your test setup was functional. Once you get to the test, once you've scrolled forward, you see the applied pressure on the top and the measured milliamp value on the bottom, and error percent being calculated. In this instance, this is an example from the 729. Notice the tolerance on the top is pink or red, indicating it's outside of the allowable test tolerance, greater than that 0.2%. If we select auto test, the calibrator goes through and automatically documents the applied pressures, the measured milliamps, and the error percent, and gives you pass-fail on the result. Notice the result there in the middle indicates failed. Once that's done, the technician, the tag, the serial number need to be recorded, and that is tagged then with that to that as found result. Next. And since the calibration had failed, some form of adjustment was required. If this was an analog transmitter, you'd adjust 0 and span. For a HeartSmart device, there's a number of adjustments that you can make to the device. First and foremost is the zero trim, the offset trim. First step to ensure that any electronic offset that's developed with the calibrator is nominalized. And then trimming the milliamp signal on the output of the transmitter. Trim the 4 and the 20 milliamps, ensuring that the 4 to 20 milliamp output that is one of the more drifty aspects of a device are within limits. And in the event that zero trim and milliamp trim doesn't get you to the performance that you need, then you can trim to applied values. Apply the 0% pressure and the 100% pressures, and adjust the 4 to 20 milliamps to ensure they match the pressure values applied for 0 and span. Next. So once the adjustment is completed, the as left test is essentially a repeat of the as found test, and you document the post-adjustment condition of the transmitter. Okay, notice on the top screen that the errors are quite a bit smaller. We're within 0.01%, so the adjustment must have been successful. So now we select auto test, and the documented test is recorded. And you can see in the bottom screen that the test results pass, and all pressures, with the pressures applied, the measured milliamp values are within allowable test limits. Next. So next, Bob's going to demonstrate, now that the results are in the calibrator, what it looks like when you bring the results up from the calibrator and into the calibration management software. so you can view the calibration certificate and take a look at the other reports that are available. Go ahead, Bob.
All right, so on the same, we're still on that same screen. We just downloaded the results, or I'm sorry, we just downloaded the task to the calibrator. While Jim was discussing that, I pretended to go out and do a calibration. Actually, it was already done, but I'm gonna go over here to upload. And all you do again for upload is just click the upload button, and then it'll go in and bring in all of the calibration results that you have uploaded. Once you have that back into the system, it's accepted. And if I look at my calibrations, here's one that I did today on this PT100 transmitter. And if I look at the report, and it's probably going to be really small, so I'll make it bigger so you can see better. And you'll see in the report. So here's a situation where we took the 729 out to that pressure transmitter, connected up. You'll notice this report, and this is what the auditor is going to love to see because it's got all that information electronically uploaded to your software right off the 729. So this report shows your company name, shows information about the transmitter, and more importantly, in the box down here, this is where your test results are documented. And you'll see we had as found, which in this case was out of spec and failed, and you'll see it failed for every one of the test points. And this was a 5-up test that was done here. And so adjustments were made, and then you'll notice the as left results now pass. And so this information is important not only for the calibration of the instrument, but also you'll see the documents also showing you the information about your test instruments. So the software is talking to the 729, and you're keeping that information about that 729 recorded in the software, and it tells you if it's in calibration or not. So again, the auditor is going to want to know the calibration results of the instrument that you, the process instrument that you calibrated, but also the auditor is going to want to know, if your instrument used to test the device was in calibration as well. So that pretty much covers the report capabilities of DPC Track 2. Again, you can go in and search for all kinds of, you can look at the history of the calibrations, for as long back 10 years or whatever. Every time you calibrate, you can do trend reports, and you can have test reports for all of your devices, and it's all stored in the database of the software. It's not sitting in a file cabinet, so much easier to get a hold of. Okay, that pretty much covers that. Yeah, get you back going here, Jim, on this part. Hang on a second.
Okay. We have a few closing slides to talk about the benefits of the system. Next. So as Bob showed you, now we have electronic records of the calibrations stored in the database. And these records are stored for recall and printing as needed. The calibration date is automatically updated in the database, and the next calibration due date is set based on the interval in the software. Next. One of the takeaways is the efficiency of route-based calibrations using documenting calibration and calibration management software can save up to 50% on calibration maintenance labor, making technicians more efficient. Having the technician armed with a calibrator with a calibration route makes the technician in the field much more efficient than returning to the shop after each calibration is performed. Multifunction calibrators minimize returning to the shop to get additional tools. The efficiency of performing pressure tests with the 729, as Bob showed, makes automatic pressure calibration more efficient. It saves time, makes the technician more efficient, and improves the quality of the calibration result. And documented calibration results can assist in passing audits or other requirements where calibration records are required. Next. So to summarize, calibration is a critical practice to remove variability and maintains safety and processes. Documentation of calibration history enables advanced analysis techniques. Field documentation with the documenting calibrator eliminates transcription errors, enables data to be uploaded to calibration management software. Calibration management software can be used to sort the calibrations due into routes, to download into a calibrator, and maximizes the use of skilled personnel. And calibration management software assists in managing and interpreting documented calibration records and day-to-day workloads assignments, and helps you manage the instrumentation workload in a plant. Next. Go ahead. Next. Just a little bit about Fluke. Fluke is located in Everett, Washington. We have 3,000 employees worldwide in over 100 countries. We talked about process calibration tools today, and our host Transcat represents us and has many beyond more than just process tools. Of course, they have our DMMs, our calibration standards and oscilloscopes, the calibration management software that Bob demonstrated today, and a number of other tools. And our host, next.
Thanks, Jim.
Transcat. Yep.
Yep. If you go back one slide for me, I just wanted to highlight an offer that Fluke has ongoing that, of course, you can take advantage of through Transcat. Through June 30th, there's a gift with purchase program that they're calling Measure Up. So basically, with purchases over $250, you can choose free Fluke tools with your purchase. Details can be found at transcat.com. And if you have any questions in regards to the presentation today or any of our calibration or product offering, you can contact me. If you go to the next slide, my contact information is here at nicole.vanwert@transcat.com. I am going to, so that concludes the presentation portion of our webinar for today. So I'm going to open it up to questions right now. And if you don't know how to submit questions, you can do so through the right side of your webinar controls. I see that a couple have been submitted already, so let me get to that. First question, how would you separate identical tag IDs from different customers? Was this designed for a single site use in mind?
Bob, we want to take that?
Yeah, sure. So you can install the software that for DPC Track 2, it's intended to be installed on one computer at a location. It could, however, be used, let's say, by a contractor, and I've seen cases where they'll go out to multiple customers. And as I was talking, you can separate devices or instrument IDs by using locations, by using like a loop or equipment, and that's one way where you could identify separate locations or separate customers in that case.
Hey, Bob, I was thinking that the grouping functionality might allow you to have identical tags, but grouped into different work groups.
Yeah, the problem with identical tags is each tag has to be a unique ID, so that might make it a little more difficult if you're using the same ID tag name.
Okay.
Okay. Does the DPS Track 2 software require annual licenses to be purchased, or is there a cost per device?
No, that's one thing that is really was really nice about the software is that with a lot of more expensive software packages, you have to pay annual license fees and annual support fees, and then costs per device. And with DPC Track 2, there's no limit to the number of devices you can load into the database. Actually, it uses Access database on your computer, so the only limitation is actually the size of your hard drive. And if you have support questions, you just call 1-800-44-FLUKE, and you'll probably get me, and I can help you out.
Okay, what about compliance with the FDA's 21 CFR Part 11?
Okay,
That's you.
I'll
You,
take
Jim.
that one, Bob. So the
Okay.
the DPC Track 2 does not have the scripts for compliance with 21 CFR Part 11. In the instances where we run into the requirement for compliance with that regulation, we would typically refer the customers to Prime Technologies and the ProCal product, which is the product up from DPC Track 2 that can be multi-user as well as offers compliance to that regulation.
Okay, let me see. How many tasks or procedures can be loaded into a 7.5X? How many are recommended?
Any other questions?
How often? Can you hear me, Jim?
Yeah, I got it. I'll take this one.
Yes, I can.
Yeah, so I've done a few tests myself with it, but there's conservatively you could have up to 50 calibrations on a 754 easily. But I would recommend, just for safety precautions, just do a day's worth of tasks, and then just upload it at the end of your shift. That's probably the easiest way, but there's enough memory to store quite a bit of calibration tasks and test results.
Okay. How do DPCs help ensure tasks are performed as downloaded?
So
that tends to point to that usage count, right? Sorry, that tends to point to that usage count that I was referring to. If the technician has gone out and performed 4 calibrations that were downloaded by the supervisor and brings them back, and the usage count and all the tasks that the supervisor wanted the user to do show as 0, the technician has gone and done the calibrations, but not using the downloaded tasks. So that's something that the supervisor may have a comment with or a discussion with the technician about.
And one other thing the 729 does that's pretty cool is when you load your tasks up and you connect up to your HART device, it's going to look and verify that the serial number matches the serial number of the device that you've downloaded. So you verified 2 ways that you've got not only the tag ID but the serial number, so it matches up exact.
Okay. Does the HART functionality in the 729 or the 754 replace the need for a HART communicator?
That's a good question. We get that a lot. The 754 does not have the full functionality of the Emerson 475 or the Trex unit. The philosophy and the design of the product is intended to not require a communicator for doing routine calibration and maintenance. So essentially covering the trimming functions and the routine maintenance functions that a field calibrator would be required to have and perform, but it is not a direct replacement for the Emerson communicator.
Okay. That looks to be all of our questions. That concludes our time for today then. If you do have further questions, you can submit them directly to me at nicole.vanwert@transcat.com, or you can also, to find out about Transcat's product and service offerings, please visit us at transcat.com. Thank you everyone for joining us today, and thank you Jim and Bob from Fluke. We hope everyone got something out of the presentation and that you continue to join us for future Transcat e-learning webinars. Thanks so much, and you will all receive a follow-up with the slide recordings. Thank you.
Thank you, everybody.
Thanks, that was fun.